Next question, 71st. It's a direct question. Which is least likely to act as Lewis base? So the answer is BF3. BF3 is a Lewis acid.
Okay. Amount of.
So why it is a Lewis acid?
This could be.
It is electron deficient.
It's it. Yes.
Why it is electron deficient?
That's it.
Central atom boron
You can see. She went in the pictures.
boron has only 6 electrons. That is 2 electrons less than octet.
But
Guaranteed.
opposite.
2 electrons less than
Potential.
Doesn't
octet.
hooks.
Now these Lewis acids with a vacant orbital accept an electron pair and form coordinate covalent bonds. So BF3 can become BF4 minus, which is called a borofluoride ion. This is a Lewis acid. This is a Lewis base. The new bond formed is indicated with an arrow. The arrow represents coordinate covalent bond or dative bond. So this is all about, or I can give one more example. BF3 also combines so I write it in the new slide or above slide.
Oh, here it.
So BF3 can also combine with ammonia. In ammonia you have central atom nitrogen with an extra electron pair. The electron pair it can donate to the vacant orbital. This is vacant orbital.
Got it.
Then the resulting compound is BF3 arrow NH3. We call ammonia boron trifluoride. So again this acts as a Lewis acid, ammonia acts as a Lewis base. So whenever a Lewis acid combine with a Lewis base, the resulting one will have an extra or new coordinate covalent bond, which is indicated with an arrow. The arrow is pointing from donor to acceptor. The arrow in which direction? Donor to acceptor. If you want one more example, I'll give water molecule in which oxygen has 2 lone pairs. It combines with H plus. H plus has vacant orbital It is an electron pair acceptor. It is a Lewis acid. Water is a Lewis base. So water donates an electron pair to H plus. And the resulting one is H3O plus,
It's hard
which is called hydronium.
to
Hydronium ion.
this. No, thank you.
So many molecules having extra lone pairs act as Lewis bases, or the molecular ion having vacant orbitals act as Lewis acids. In one neat exam, this question was asked. Ethers stored in the laboratory for a long time cannot be directly heated because of fear of explosion. That is due to the formation of.
Okay.
This is the previous question. Concept is same. What is the question? Ethers
Street.
which are stored for a long time cannot be directly distilled or heated due to fear of explosion, due to the formation of. So the answer is ethers. Ether and water are friends only. In two hydrogens of water are replaced by two alkyl groups, then we call it as ether.
Well,
These ethers, when you store for a long time, they combine with one oxygen atom having a vacant orbital. So ether donates a lone pair to oxygen. Here oxygen acts as a Lewis acid. Ether acts as a Lewis base. And the resulting compound is an ether peroxide.
this one.
We saying out.
Ether peroxide.
That happened. You know,
Arrow here. This is called ether peroxide. You know, peroxides are highly unstable.
she gets at least you.
Ether peroxide.
Two. Well,
So, which compound is responsible for explosive nature when ethers are stored for a long time? R2O. This is ether peroxide.
Okay.
equal.
Oh, sorry, arrow should be given.
Okay. Invisible.
Arrow should be given this direction because ether is donating electron pair. Arrow is always given from donor to acceptor. Oxygen will have total 3 pairs. Actually, what is oxygen configuration? Oxygen configuration is 2s2 2p4. Do oxygen has any vacant orbital? No. But when it is going to combine with ether, these two unpaired electrons, they become paired up. So when this electron goes into this entire orbital becomes vacant. This is called electronic rearrangement. So how oxygen acts as a Lewis acid, though it has no vacant orbital, because the two unpaired electrons here, they become paired up. So after pairing up, this is the configuration. This is what we call electronic rearrangement. So 2s2, 2p4. Actually, it should contain two unpaired electrons. They become paired. So that orbital become vacant. This pairing of unpaired electron is against of the pairing of unpaired electron is against of option A, Pauli's principle, option B, Hund's principle, option C, Abbo principle, option D, both Pauli's and Hund's principles. The two unpaired electrons are being paired up. It is against which rule? Yes. Any doctor? Your names are difficult to pronounce, that's why only Rudolph, Dr. Rudolph I can recollect the name, because it is similar to Adolf. Rudolph. So actually, you are not revising the subject thoroughly. When P subshell containing Px, Py and Pz orbitals, which are equal in energy, they are called degenerate orbitals. Degenerate orbitals are first filled with one electron each with the parallel spins. After that, pairing occurs. This is as per Hund's rule. Suppose if I pair this electron here, I am violating Hund's rule. So that same point. Pairing of unpaired electrons in oxygen atom, pairing of unpaired electrons in oxygen atom is against Hund's rule. The same point you have studied in your coordination compounds. In coordination compounds, if their ligands are very strong, the strong ligands, what they do? They force the pairing of unpaired electrons and it became a low spin complex. Complexes with strong ligands form low spin complexes. Complexes with weak ligands form high spin complexes. See, everything is connected. Chemistry, generally people think that this chapter is different, that chapter is no. We started after all Lewis acid and we are going to any extent we can go like that. So students should be able to connect the things, similar things. So that is only possible if you are thoroughly revising the subject periodically. Then immediately flash of light, you can think, okay, this is Lewis acid. In all coordination compounds, the central metal ion is a Lewis acid. The ligands are Lewis bases. So formation of a complex is neutralization according to Lewis acid base theory. Formation of a complex is, number one, neutralization according to Bronsted theory. Number two, neutralization according to Arrhenius theory.
Right.
Number three, neutralization according to Lewis theory.
Sure. Good. Maybe.
Neutralization according to all theories. So the answer is neutralization according to Lewis theory. Because ligands act as Lewis base. Central metal ion act as Lewis acid. When a Lewis acid combines with a Lewis base, that is a new day-2 bond is formed. Day-2 bond is nothing but coordinate covalent bond. And that is neutralization. Don't think like in Arrhenius theory, when an acid and base combine, it gives salt and water. In Arrhenius theory, when an acid combines with a base, what you will get? Salt plus water. In Bronsted theory, when an acid combines with a base, you will get a new conjugate acid-base pair. So in Lewis theory, when an acid and base combine, it will give a new coordinate covalent bond. So neutralizations are three types. What is neutralization according to Arrhenius? Resulting as salt and water. What is neutralization according to Bronsted-Lowry? Formation of a new conjugate acid-base pair. What is neutralization according to Lewis theory? Formation of a new coordinate covalent bond or day-2 bond. Okay.
Understand. Differential. Like this.
Now the next question.
Look at
Ammunition.
first of all.
KMnO4 can be prepared from K to MnO4.
Right.
They have given an equation. MnO4 2 minus plus 2H2O.
Sassy.
This is 3 MnO4 2 minus 2 MnO4 minus plus MnO2 plus 4 OH minus. Now they want to remove this OH minus ions. Then the forward reaction occurs. Now it is a reversible reaction. I wrote 2 arrows. So whenever these OH minus ions are removed from the right side, product side, as per Le-Chatelier principle, the equilibrium should shift in the forward direction. OH minus ion is a base. A base can be removed by adding an acid. So you can add HCl. So that 4 HCl react with 4 OH minus to give 2 H2O plus 4 Cl minus. You can't add KOH. No reaction occurs. KOH is a base. OH minus is also a base. A base can't remove a base. Now the third option they have given, SO2. SO2 in water gives H2SO3, sulfurous acid. This sulfurous acid can react with base. So this is also possible. This is possible. Now one more option they have given, carbon dioxide. You know, carbon dioxide in water give carbonic acid. H2CO3.
Out there.
So this is possible. So only one is not possible. Three possibilities are appearing. But only you have to choose one option. So right, SO2 and HCl are ruled out.
This is it. Is that fire?
SO2 and HCl are ruled out or are not considered because they are reducing agents and they are reducing agents and they reduce the formed MnO4 minus
No.
and they reduce the formed MnO4 minus into Mn2 plus ions. They reduce the formed MnO4 minus, that is permanganate ions. What is MnO4 minus called? Permanganate. What is the left side MnO4 2 minus called? Manganate. So it is an oxidation, manganate to permanganate, because manganate has plus 6 oxidation number. Here it is plus 7 oxidation number, but in MnO2 it is in plus 4 state. So plus 6 to plus 7 oxidation, plus 6 to plus 4 reduction. So same manganese is undergoing both oxidation and reduction. We call it as a disproportionation reaction.
How is the celestial
Disproportionation. So write what is a disproportionation reaction. The reaction in which the same element undergoes both oxidation and reduction. The same element undergoes both oxidation and reduction is known as disproportionation reaction. Other examples: P4 plus NaOH plus H2O gives rise to PH3 plus H2PO2 minus, or
a little bit.
have 3 NaH2PO, 3 NaOH, 3 H2O. So this is balanced equation. White phosphorus react with NaOH in aqueous medium to liberate phosphine gas. PH3 is phosphine, and 3 NaH2PO2, sodium hypophosphite. Now here what is the oxidation number of phosphorus? P4. Whenever same atoms combine, it is called homoatomic molecule. There is no charge on them. Oxidation number 0. In PH3 it is minus 3, because each hydrogen is plus 1. and 3 hydrogens carry 3 plus. Obviously phosphorus should carry minus 3. Here it is plus 1. Now 0 to minus 3.
T.
Decrease in oxidation number. It is called a reduction. 0 to plus 1. Increase in oxidation number. Oxidation.
I got back in the
Now is it undergoing disproportionation or not? Which element is undergoing disproportionation? Phosphorus. It is undergoing reduction from 0 state to minus 3 state. It is undergoing oxidation from 0 state to plus 1 state. So same phosphorus is undergoing both oxidation and reduction. It is a disproportionation reaction. Now Cl2 plus 2 NaOH, NaCl plus NaOCl plus H2. All these are well-known disproportionation reactions which are present in your NCERT textbook. NCERT textbook, you have to treat it as a Bible. Your book should be totally twisted, worn, and totally pages are about to tear. That much way you have to use the book. Don't think it is a neat and just bought from the bookstall. So the pages, everything should be mutilated. That much versatile use you should have. Underline, noting the points here and there. Every day turning the pages, again seeing what you have noted there, where you have underlined or highlighted. So that much intense preparation. As I am telling repeatedly, students' role is 90% or 80%. Our role is only SIRD role, or my role, or the entire scenario role is only 20%. Hope some of you definitely become toppers of Meghalaya, and even if too altruistic or optimistic, some of you may become the national toppers also, we don't know. At least we will first think that this batch will get some toppers from the entire state. Later we can think toppers at the national level. So here chlorine undergoes disproportionation, 0 to minus 1, 0 to plus 1. Actually this reaction in cold dilute condition, cold dilute NaOH, I am giving the next example for this concentrated 6 NaOH, 3 Cl2 gives 5 NaCl plus NaClO3. This is the balanced equation. Here also chlorine from 0 to minus 1.
This phase is
minus 1 and 0 to plus 5. This is another disproportionation. So all disproportionation you should gather at one place. Now I am giving one more disproportionation, that is sulfur disproportionation. Shall I go? Sulfur disproportionation. Sulfur plus NaOH gives rise to Na2S plus Na2S2O3
That's
plus H2. 4S, 6 NaOH, 2 Na2S and 3 H2.
that's good.
Here sulfur is 0, here it is -2, here it is +2. 0 to -2, reduction. 0 to +2, oxidation.
Looking at that.
You give just this much space for future disproportionation reactions. Whenever they come, we'll add to the list. Already here we had phosphorus, sulfur, chlorine 2 conditions 4 and permanganate. So total we have given 5 examples. So in permanganate formation from manganate, how the OH minus ions are removed? Are they treated with HCl? No. Are they treated with SO2? No. Because HCl and SO2, though they are acids, they further reduce MnO4 minus to Mn2 plus. That's why they cannot be used. And KOH cannot be used, one of the options. So the only left option is carbon dioxide. Carbon dioxide in water gives carbonic acid, H2CO3. This carbonic acid is called soda water. Whenever you take any effervescent drink like Thumbs Up or Coke or any Sprite, anything, bottle which you open with full of bubbles it is coming, it is a carbonated drink. The acid is carbonic acid, H2CO3. So carbonic acid can remove the OH minus ions, but it won't affect the other parts of the reactants or products. So this is the explanation for that question. Next. Which of the following is electron deficient? Write a point. All the compounds of boron, are electron deficient. All the compounds of boron are electron deficient. Because boron cannot have octet of electrons around it. So here they have given diborane B2H6. Now diborane has two BH2 groups
Yep.
and two hydrogen bridges. It is called a diborane. What is the formula? B2H6. Suppose if it breaks, it gives two BH3 units. In each BH3 unit, boron has how many bonds? 3 bonds. Bond means 2 electrons.
Right?
So total boron has how many electrons? 6 electrons. 6 electrons means it has sextet of electrons, not octet. So that is the answer. Next question. Structure of the compound IUPAC name of 3-ethyl 2-hydroxy 4-methyl Hex 3 in 5 ionic acid. That you can easily do it. Do it require explanation? Yes or no? IUPAC name. One triple bond.
Ultraviolet. Windows. Q. BT.
Which one?
Okay.
Other.
I just gained the people signal and finished the TV.
Still don't come out that.
It's enough.
Here a double bond. Now, so you have to start the numbering with the chain terminating group. COOH is called a chain terminating group. With that the chain terminates. Don't further progress or proceed. This carbon is given as number 1, 2, 3, 4, 5. This is the longest chain. 1, 2, 3, 4, 5. Second carbon is having what? Hydroxy group. Fourth carbon is having what? Methyl group. Third carbon is having a double bond. 3 ene. Fifth carbon is having a triple bond. 5 ine. So all these are present in option 2. 3 ethyl. This is ethyl group. 3 ethyl. 2 hydroxy. 2 hydroxy. 4 methyl. Yes. Fourth carbon is having methyl. Hex. Total 6 carbons. Hex. 3 ene. Third carbon is having double bond. Ene. 5 ine. Triple bond. Oic acid. So that is the nomenclature. Which of the following is not a monomer for high molecular mass? Silicon polymer. 75. So option trimethyl silicon chloride. Why trimethyl silicon chloride? Because if you do hydrolysis, you will get trimethyl silicon hydroxide.
To know that.
Now this will combine with another similar compound and a water molecule is eliminated and only you will get a dimer. You can't get a polymer because with the 2 units joined with each other with oxygen atom. So with this compound you can't further increase the chain length. Trimethyl silicon chloride is first converted into trimethyl silicon hydroxide by hydrolysis. So it will combine with another unit of trimethyl silicon hydroxide. 2 units combined. A water molecule is being eliminated, resulting a dimer, not a polymer. So that is the answer. So what are the uses of silicones? Silicones are water repellents used mainly to stop the leakage of water. Silicones are water repellents. They are mainly used to stop the leakage of water. And another important application, suppose he wants to enter into Bollywood as an actor and he wants to change his shape of the face, nose or something. So he should approach a plastic surgeon. He will implant silicones. Silicones are body compatible. They are used in surgical implants for beautification purposes in plastic surgeries. So many cine actors, they have undergone silicone implants. So to have a better look, nowadays the 3D images, the computer will show you your face will be changing like this or like this, like this. 3D imaging. And you can tick, yes, I want like this. Then the plastic surgeon will start doing the work. So he will implant silicones. So their body won't reject them. They are compatible to the human body.
What it does?
But you have Botox. Botox is not for you. For old people, if they want to have the face very young. So somebody asked me 3-4 days back, so what will be your age? So I wanted to tell him 90 years, but I asked him to guess. He said anywhere between 55 to 60. Yes, he is correct, yes. So, this Botox is also done by dermatologists who are highly skillful. Botox is a very dangerous bacteria that is given to the epidermal layers. If accidentally the injection goes into the body, that is highly poisonous, death occurs. So only epidermal layers they give the Botox injections. Immediately the skin become entirely wrinkle free. You will look very young. Rudolph, you can do it at 90 years of your age and become young again. Sure, okay. Next. Which of the following statements about interstitial compounds is incorrect? Second option is incorrect. So what are interstitial compounds? So whenever we try with this, in metals, the metal atoms are orderly packed like this. Of course, same size, here different sizes we are getting.
Really?
Okay, I will go for some normal way. This is how metal atoms are closely packed in a 3D pattern. This close packing of metal atoms in a 3D pattern is called crystal lattice or space lattice. So what is the meaning of crystal lattice or space lattice? It is the orderly arrangement of constituent particles in a three-dimensional pattern. What is a crystal lattice or space lattice? It is the orderly arrangement of what? Constituent particles. In what form? In a three-dimensional pattern. Suppose if you go to or you are visiting a fruit stall, you will arrange all the apples in different layers in a 3D packing. That is apple lattice. Or if you arrange oranges in many layers, orderly arrangement, you can call it as orange lattice.
Okay, Lisa.
All metals are crystal lattices. All metals are crystalline in nature. Means what? In all metals, the metal atoms are orderly packed in a 3D pattern.
Got it.
During this 3D packing, what happens? There are some gaps, they are called voids or interstices. These are called
Ports. And
so these are called voids or interstices. STICES. Right, next point. If transition metals are heated in the atmosphere, of non-metals like carbon, hydrogen,
And
nitrogen, etc., etc. So what are the non-metals? Carbon, hydrogen or nitrogen, like that. If they are heated in the atmosphere of non-metals, the non-metal atoms occupy the non-metal atoms occupy
okay.
the interstices or voids. They occupy the interstices or voids, and the resulting compounds are called interstitial compounds. And the resulting compounds are called interstitial compounds. Suppose, listen to this, if carbon atoms occupy the gaps or voids, the resulting compound is called an interstitial carbide. Suppose if hydrogen atoms occupy the gaps, the resulting compound is called interstitial hydride. If nitrogen atoms occupy the gaps or voids or interstices, the resulting compound is called an interstitial nitride. And you know how many gaps are filled, how many atoms are filled, we don't know. That's why we can't write a proper formula for interstitial compounds. So interstitial compounds, they don't obey normal valency rules. That's why they are called non-stoichiometric compounds. So write that point. Interstitial compounds do not follow normal valency rules. Hence they are called non-stoichiometric compounds. Hence they are called non-stoichiometric.
Why should
Look at this.
I need to the actually the angle of it.
B4C, boron carbide.
No.
What is the valency of boron? Boron valency is 3. What is the valency of carbon? 4. So 4 should come here, 3 should come here for writing the formula. Expected formula is B4C3. This is expected as per normal valency rules. Carbon valency 4 should come this side. Boron valency should come like this. So what is the expected formula? B4C3. But actually observed formula is B4C. Boron carbide, very strong in nature.
Legally gone.
Very strong. Means very hard. You can't break the fibers of boron carbide.
Yeah.
That's why the fibers of boron carbide are used for making bulletproof waistcoats. The prime ministers and some journalists working in war areas, they wear a waistcoat. Because whenever some shooting occurs, generally shooters mainly target the heart region. Of course, they may target head region also. But mainly, most of the shootings occur in the heart region. That's why they wear a waistcoat that is made up of with the fibers of boron carbide. So boron carbide fibers have very high tensile strength, very strengthy. So even if you hit with a bullet, it won't pierce through the jacket. That much preventive it is. I think you heard about silicon carbide, SiC. Silicon carbide, SiC, which is called carborundum, which is used as an abrasive. What is abrasive? Abrasives are those substances which make others smooth. They won't themselves become smooth. They always remain rough. They make others smooth or sharp. That's why abrasive materials are used to sharpen the knives, scissors. So what are abrasives? They are very hard substances which, when subjected to friction, make others smooth. Even for any wooden furniture, the carpenter will apply abrasive paper and make the wood smooth. Then he will apply polish. So do you understand what are abrasives? What are the two natural abrasives in our syllabus? Natural abrasives in our syllabus, one is diamond, the second is corundum, Al2O3. Write that point.
Is
Diamond and corundum. Diamond and corundum. Corundum means within brackets Al2O3 are the two natural abrasives. Are the two natural abrasives AbRaSiBes.
tortuous.
So I don't know in Meghalaya how you are getting water. You are making groundwater to tap or only the rainwater collect and use.
Oh, it's fun.
Bores also there.
What was what the what is there?
Groundwater you tap it
Then was
or simply because rains are more here. You can collect huge rainwater in the entire season and use for the rest of the year.
Club.
I don't know. But generally when you are going to recover groundwater, you have to do a drilling to the earth and get some water from the ground. That is called borewell. A rig will, you have to call a rig. The rig person will drill the earth. So while drilling, sometimes a big rocky area will come. Inside the earth, we don't know. Not all the earth is smooth or soft. Some rocky layers may come in between. Normal metallic rigs cannot drill that rock. So what the drill person will do, he will remove the rig and attach a diamond there. Diamond means don't think ornamental quality diamond. Ornamental quality diamonds should maintain 3 C letters in high grade. 3 C letters: cut, clarity and carat. If these 3 C letters are in high level, that is a good quality diamond. It should be properly cut. It should be very clear inside. Cut, clarity and carat. Carat means weight. 1 carat is equal to 200 milligrams. If these 3 C letters are in high level, that is a very good quality diamond. There are some diamonds in British Museum. Even today they can't be valued. Their valuation is so high, in trillions of dollars or pounds. No gemologist who is specialist in gemstones can value them. Some lakhs of crores of rupees. So they can't value. That's why what they do, they call the insurance people and approximate it. Okay, this value is this much. For that we pay this much insurance to you. Because there is some theft occurs, the insurance company should pay the money. Or if any earthquake comes, the diamond is totally destroyed, then the insurance company pay compensation. So why diamonds have that demand? The answer is, when a light ray enters into the diamond crystal lattice, there are many planes in the diamond. The light ray which entered into the diamond lattice undergoes several times reflection. We call it as total internal reflection. Total internal reflection makes that glittering nature. But this is all about good quality diamonds. But bad quality diamonds are used for drilling the rocky areas. Okay, coming back to our next question. So in the 76th question, second option is a wrong statement. All the remaining are true regarding interstitial compounds. Which one of the following molecules do not contain a pi bond? CO2. CO2 is a linear molecule with 2 pi bonds. So I will draw the structures of all these. CO2 is a linear molecule with carbon sp hybridized linear. The second one H2. H2 is a bent shape or angular shaped molecule with two bond pairs, two lone pairs, sp3, angular. It has no pi bonds. Both are sigma bonds. This is sigma, this is sigma. Double bond always consists of one sigma, one pi. So carbon dioxide contains how many pi bonds? 2 pi bonds. Now this third one is SO2, sulfur dioxide. This is also angular. Angular. sp2 hybridized. 2 pi bonds are present. Double bond always consists of 1 sigma, 1 pi. Next is NO2. NO2 is also angular. It has a single electron, odd electron molecule, and this is a dative bond. Dative bond with 3 lone pairs. This is NO2. It has 1 sigma and 1 pi. So these molecules contain pi. No, in water there are no pi bonds. Next verse is direct antiseptics and disinfectants. Either kill or prevent growth of microorganisms. Identify which of the following statement is not true. Dilute solutions of boric acid and hydrogen peroxide are strong antiseptics. That is wrong. They are weak antiseptics. But anyhow, this chemistry in everyday life was removed from your NEET syllabus. So 78th you round off and mention deleted.
Go.
Now 79th.
Because what?
Among the following ethers, which one will give? Which one will produce methyl alcohol and treatment with hot concentrated H?
What about the
That's fine.
so that's
OCH. This is option 1. It's very important. When you treat ethers with HI, H plus I minus, first what ether will do? It will donate a lone pair to H plus. My dear H plus, don't worry, you are a Lewis acid. I am a Lewis base. Because I have lone pairs, I can donate. Lone pair donor is Lewis base. H plus is Lewis acid. Lone pair acceptor. Then you will get CH3, CH2, CH2, OH, O get plus CH. This is called oxonium ion. Now O is worrying a lot. I am more electronegative atom, now I am carrying positive charge. Generally O want to carry negative charge. It is a more electronegative atom. But here after donating the lone pair, What charge it is carrying? Positive charge. So if you don't want to carry positive charge for a longer time, it is a headache for him. That's why the bond is going to fission. The I minus is going to attack the methyl group here. Then this bond shift towards oxygen.
Right.
This. Making it to down. 7. Release. Release. But. Successfully.
So this is bond shifting. So finally what it will give? CH3, CH2, CH2, OH
That is.
plus CH3I. This is SN2 reaction.
Gaussian is button.
So first option won't give methyl alcohol but gives methyl iodide. One part is methyl iodide, the other part is propanol, 1 propanol.
And
Now we go to the second option. Second option.
keep on. I was taking
CH3, CH2,
What?
CH, CH3, O, CH. This is option B. Again with HI, H plus I minus. Same mechanism. This will donate and you will get an oxonium ion.
You.
OH plus CH3. So I minus act as a nucleophile. Whenever nucleophile is going to attack the least sterically hindered carbon, that is methyl carbon is least sterically hindered, it is called SN2 reaction. So here what you will get? CH3, CH2, CHOH, CH. Plus this part become CH3I. You will get 2-butanol. What is the compound formed here? 2-butanol plus methyl iodide. Now we are going for option 3. Here a tertiary alkyl group is given. CH3C, CH3 thrice, OCH3. What is its common name? What is its IUPAC name? Common name is methyl tertiary butyl ether. One part is methyl, the other part is tertiary butyl ether. What is IUPAC name? In IUPAC, ethers are called as alkoxyalkanes.
Actually,
Here it is 2-methoxy, 2-methyl propane. This is the longest chain. Second carbon is having methoxy group. 2-methoxy 2-methyl, what is the chain? Propane. 2-methoxy 2-methyl propane is IUPAC. I think in your up to 12th class where you have studied, in here only Shillong and adjoining places, in Meghalaya only, somewhere here and there. But 2 years I think in the 11th and 12th, you totally enjoy. To be frank, yes or no? That's why when I want to recollect certain things, student's face we can understand. So the face is very blank and with a question mark. So that I can visualize. That's why for solving just one paper we are taking this much time. But of course, anyhow, let the past is dead, it is over. Now we are in the present. At least you learn now, learn the things now and consolidate the things. Learning is one aspect, consolidating is second aspect. Learning and again leaving again comes to the same place. Not only you learn now, but also you have to discuss with your friends, consolidate. Whenever you have free time, somebody can give a seminar. Student seminars will be there. That also you can self-evaluate. You can conduct a quiz. Each row, you take one participant, select one participant and choose a topic. He will or she will speak here. That increases your confidence also. So actually our system, earlier we used to think our Indian education system is very strong. But later I came to know, though American students won't study, better you are sitting. They don't sit also. So with a gun in their pocket, they will be roaming here and there. If teacher reprimands or strongly says something, he will shoot the teacher and also fellow friends. Shootings are more common in American schools. Gun culture is very common there. But I came to know from many of my students and also my daughters who studied there. In MS, means Master of Science, the classes are only 2 days. No, not 2 days. 2 days into 2 hours. So total workload per week is only 4 hours. That 2 hours time, it all depends on the availability of the professor, not like us. The professors are working here and there, scientists, some visiting faculty here and there. So depending on that faculty availability, he will conduct a class night 8 to 10. Students have to attend. So I thought it is a very weak system, only 2 days into 2 hours. But it is very strong. In the 4 hours, whatever he taught, the entire class is divided into groups. Each group is given a task. They have to prepare a seminar. One group has to prepare a quiz. One group should submit a thesis on that. Like that, group tasks are given. Plagiarism is not allowed. Plagiarism means copy. Copying from seniors or from the internet, not allowed. Professor easily identifies. If he feels that it is copied, he will be immediately disqualify that session. So the remaining 5 days, students are struggling hard to give a new shape to the given work. So they are learning in the meanwhile. In the process, when you struggle, you learn. When you don't struggle, we don't learn. That's how they are becoming more and more self-reliant or self-sufficient in their activities. So that makes them stronger in their education. So actually in our Indian education, what we are dumping so much knowledge on it. That is also good. But the knowledge must be assimilated, digested, and recollected. So here also there is one way, but there is a different system there. And school kids, in the school diary, front page, back side, last page, police numbers will be given. Because if the mother or father strongly ask or anything, punishes the kid, the teacher educate him. If your mother is telling any harsh things to you, or if your father is beating, call these numbers. So every day they educate.
Yeah.
That's why the students are very much known the police numbers. You suppose as your own son or daughter, you just hit or strongly remind him anything, he will immediately call the police. Police will come and catch you and arrest you and produce before a judge. Judge will give a punishment like this. You work 10 days in an orphanage.
Right.
You have to apply for leave to your company and work 10 days in orphanage or old age home, so that you learn the pain. You should not punish the students. So corporal punishments or small reminders are also not allowed in the US education system. That is a different system, ours is different. But from your background, what I understand, in the total 2 years of your 11th and 12th, which you call higher secondary year, higher secondary, so different states call different names. In CBSE we call 11th and 12th. In Andhra and Telangana we call it intermediate. In Karnataka it is called pre-university, PU. Different names. Okay, in Tamil Nadu also it is called higher secondary. So in higher secondary, luckily, you the future doctors, fully enjoyed. So enjoyment period is over now. Now it is a time for dedication coupled with hard work. So any deviation you can't. So here also the first step is same. That is the formation of oxonium ion. OH plus CH. Now this I minus, the I minus is thinking to attack this carbon. Then this carbon says, no, don't go that side. Please come this side now. In the previous A and B choices, you have attacked the methyl group and you formed methyl iodide. Now this time don't go that side. Come towards me. Then I minus asked why? Because I already done the job. Why you are asking to come towards you? No, when this bond breaks, I am going to form a tertiary carbocation. Tertiary carbocations are more stable. That's why I minus attacks here. And the resulting compound is tertiary butyl iodide. And this part becomes
Hey, here.
methyl alcohol.
She did. Teach me so.
So the question asked which will give methyl alcohol.
It's really.
So why I minus is attacking? Now, one more option. I think it is given or not. Otherwise I will give. No.
That's it. It's on it.
So in the last option, again you will get methyl iodide. Last option, D option. And the remaining part become isobutyl alcohol. This is the last option. D option, CH3, CH3, CH2, OCH. The ether bond fissions like this is called ether bond fission. So this become HI. You will get CH3 twice CH, CH2OH plus CH3I. You will get secondary butyl alcohol, not secondary, sorry. This is isobutyl alcohol.
Again, taking it.
Now write some more information here.
And this. See, echo.
The given ethers in the above question, are unsymmetrical ethers. The ether bond, next point, the ether bond fission with HI, with hydrogen iodide, with HI in unsymmetrical ethers occurs A. I minus usually attacks I minus iodide ion usually attacks the least sterically hindered carbon the least sterically hindered carbon forming an alkyl iodide
That is a lot.
and the remaining part
And aspect.
becoming an alcohol.
Jesus was what? And okay.
Within brackets, option A, B and D. Options A, B and D. Because with the same question we are discussing the concept. Now the next point, B. If one of the alkyl groups attached to ethereal oxygen, if one of the alkyl groups attached to
Go out. You got
Ethereal oxygen is a tertiary alkyl group
You check it into the
is a tertiary alkyl group. The I minus attacks that tertiary carbon forming tertiary alkyl iodide.
before the thought.
Tertiary alkyl iodide, within brackets, tertiary carbocation is more stable.
Yes.
Tertiary carbocation is more stable. And the remaining part become alcohol.
Listen.
Wow. Wait, got it.
Next point, C.
Yeah.
If one of the group attached to ethereal oxygen,
Yeah, what?
if one of the group attached to ethereal oxygen is a phenyl group, is a phenyl, PHENI, PHENYL, phenyl group. What is phenyl group? C6H5, benzene minus hydrogen gives phenyl group, C6H5, phenyl group. That phenyl group converts into, that phenyl group converts into
Man, it's it.
phenol.
Yeah, but done is
That phenyl group converts into phenol,
the same.
and the remaining part become alkyl iodide.
The entire thought put in for and connection to
You write this example. C6H5 OCH3.
it.
This is called methyl, comma, phenyl ether. This is common name. What is IUPAC name? Methoxybenzene or Yenisol. These are IUPAC names. Now when this is pentyl group, which is also called isoamyl group. If isopropyl group is connected with OH group, what we call? Isopropyl alcohol, which doctors call as rubbing alcohol. The isopropyl alcohol, CH3 twice CHOH, is having very good antibacterial, antiviral nature. That's why whenever doctors want to make an injection, they take a cotton swab and dip in isopropyl alcohol and rub there. So this is called rubbing alcohol, isopropyl alcohol. Even in COVID time, we used already many sanitizers. But WHO recommends the sanitizer, which is a good quality sanitizer, must contain more than 70% of isopropyl alcohol.
That's it.
But people don't know about it. So generally, most of the companies, they mix ethyl alcohol and sold as sanitizers. So they are not good sanitizers. So what is good sanitizer? The one which contain more than 70% isopropyl alcohol.
It was. It. Geometrics like this.
Understand. You're connecting because I can separate.
Next one. Okay. For the next one, 82. You write a point first. In nitrobenzene, the NO2 group the NO2 group is electron withdrawing it is electron withdrawing. It is called minus M and minus I. Dr. Rudolph, what is minus M minus I?
You even inside of this. Electric.
What is your name, doctor?
Nagi.
Not it.
N.A.
N-A-D-I.
Nadine. Okay.
That's the way. Picture.
What is minus M? Negative mesomeric effect. What is minus I? Negative inductive effect. Do you have any idea? No idea. She has the idea. Yes.
It's very good.
Try. So Dr. Nadeem, Dr. Rudolph, another doctor,
What do you like so? Look at them.
Kohima,
D-O-M. D-O.
Kohima.
And the D.
Kohima is Nagaland.
Right. It's body buff on the turn.
Kohima.
Sir, and you look at that and see you thank you. Thank you.
Negative resonance effect or negative mesomeric effect. And negative NO2 causes two effects. It is minus I and minus M. It is called a ring deactivating group. It is always meta-directing. So what you are writing? The NO2 group in nitrobenzene is
Then the touch is right to
a minus M and a minus I group.
China. You feel that money.
Three.
Minus I minus M group. Within brackets, electron withdrawing group. And is always meta-directing. So nitrobenzene is again nitrated with HNO3 H2SO4 at higher temperatures. The second nitro group that is going to attack here, the second nitro group will only come to the meta position.
Face good. When
So you'll get meta dinitrobenzene.
it's going to this way.
So this minus M and minus M anyhow, you are doing a program, you are seeing the textbook and preparing your own notes. So very good things are there in your program. So by the next class, you consolidate, write what is minus M effect, what is minus I effect, and also these two effects. It is also called ring deactivating group. Next 83. Some meta-directing groups, substituents and aromatic substituents, which is the most deactivating? Again NO2. Means 82 and 83 are almost same. Meta-dinitrobenzene in IUPAC 1, 2, 3, 4, 5, 6. 1, 3 dinitrobenzene.
So,
Which one? But they asked strong meta-directing. Actually, all are meta-directing. All the 4 options are meta-directing. So in NO2, both N and oxidants, due to their greater electronegativity, they pull the electron cloud of benzene more towards themselves. That's why NO2 is the most meta-directing. CN is meta-directing. Sulfonic acid group, SO3H is meta-directing. CHO is meta-directing. COOH is meta-directing. But why we choose the answer NO2? It is very strong meta-directing. Now the next question. Question number 84.
and this question number was my second part of this conversation. I was
Generally NO2 you can write NO2 greater than. Actually this order is not very correct. Different books are giving different orders. Next we can go for CN, then COOH, then SO3H. Okay, 84. So in 84 question, 6 into 10 power 23 molecules is equal to 1 mole. Here they have given 6 into 10 power 20 molecules, how many moles? So that is 6 into 10 power 20 by 6 into 10 power 23. That is equal to 10 power minus 3 moles. Now they are asking molarity. Molarity is equal to number of moles by V in liters. Number of moles 10 power minus 3 by V in liters. 100 ml means 0.1 liter. So what is the answer? 0.1 means 10 power minus 1. It goes to numerator 10 power 10. So the answer is 10 power minus 2 molar. That is the answer. That is given in option 2. Which of the following is a polar molecule? So BF3 is a trigonal planar molecule with this vector acting in this direction. These two vectors, the resultant of these two vectors. So mu is equal to 0. Whenever mu is 0, non-polar. Second option, SF4. SF4 has total 4 bond pairs and 1 lone pair. It is having seesaw shape.
It's the
Children play in a park, seesaw, balancing. It is sp3 dehybridization. So it is not symmetrical. So mu is not equal to 0. That's why it is polar. Now the third option, silicon tetrafluoride. It is symmetrical. So the vectors, the resultant of the 3 vectors will be cancelled by the upward vector. So mu is equal to 0, non-polar. Next question, next option, xenon tetrafluoride, XeF4. It is also planar, symmetrical. 4 fluorines occupy 4 corners of a square and 2 lone pairs. So total 2 lone pairs, 4 bond pairs, sp3d2, but shape is square planar. So mu is equal to 0, means non-polar. So the only polar molecule is sulfur tetrafluoride, SF4. Which is the monomer in the neoprene? These polymers, I think polymers are also deleted, no? So deleted, but if you want to know, this is called chloroprene, CH2 double bond CH. CH double bond CH. 2 chloro, 1,3 butadiene. Butadiene. This is called chloroprene. When it polymerizes N molecules, you will get polychloroprene, which is called a neoprene. Polymerize. You will get neoprene polymer. Next.
Yes.
87. So they have taken a derivative of benzene diazonium chloride, N triple bond N plus Cl minus, and there are NO2 group here and bromine here.
Where is it?
In this group is removed, and you got a ring with only 2 substituents, NO2 here and bromine here. So what reagent you have to use here? So the answer is hypophosphorus acid, H3PO2 in water. Hypophosphorus acid in water will remove this entire group. Next question, 88th question. Actually, the aromatic character of benzene follows the Huckel's rules.
I think it was like a lot less and what if the world was like pictures and even not to the way man to be like maybe cheap out. Like it's not going to the first year. I know to do. So with what I can't want to see how do you think of it? The solution on how to them. Well that's where you see the ecosystem. So they can just vanish in the arts. Well do that. And see the end of the doing this thing.
Okay, now we are going for the second paper.
Before, less you work with all of it. They're going to teach us stuff. And that, well, we need to yes, it's been hard for us. That's
yeah, it is a state that it is dead. That's why it's a mistake.
you know it's a
And
that I think the map takes it.
we start taking given that the thing that island.
In the bus bed.
Which is
We see the this room.
apple.
Yeah, but this
In the rain.
is a bit real.
I
So what is the first question?
It's kind
Maximum number of orbitals that can be identified with the following quantum numbers.
you do this. Let me do it. Bigger. Total.
So n is equal to 3, L is equal to given as
it's
1, n is given as.
like
So when L is equal to 1,
they should
m can have
take
-1, 0, +1.
see they can
3 orbitals, px, pz, py.
have to
So when L is equal to 1, m can have 3 values indicating 3 orbitals. They are asking with m is equal to 0, they are talking only about 1 orbital. So our answer is 1.
go to the
Next question.
Assuming
Calculate the energy in joule corresponding to the light of wavelength of 46 nanometers. So E is equal to hc by lambda.
shoot.
Direct substitution, E is equal to hc by lambda.
Let it go.
So c is velocity of light, Planck's constant, lambda is given. Substitute the values,
next to
you will get the option 4 as answer. Next question, equal masses of H2 and O2 and methane are taken in a container of volume V, H2, O2 and methane. So this is the, so H2, O2 and methane, 1:1:1. This is mass ratio. Mass ratio can be converted into moles ratio. Moles ratio by dividing with their molecular weights. Moles ratio is equal to volume ratio. Is equal to volume ratio. So this ratio will be 16:1:2. All multiplied with 32. 16:1:2. This is the answer. So here you should know, to convert mass into moles, divide with molecular weight. Moles ratio is always equal to volume ratio. Next question, deleted solid state chapter. Next question, the property of colloids not dependent on the charge of the colloidal particles. Tyndall effect, write a point and Tyndall effect. Scattering of light. Scattering of light by colloidal particles. Scattering of light by colloidal particles is known as Tyndall effect. Example, the sky appears blue. The sky appears blue due to scattering of light by atmospheric dust particles. Milk is white due to scattering of light by the colloidal particles of milk. Suppose if anybody asks you why milk is always white, so milk is not a true solution, it is a colloid. Milk is a colloidal system. Of course, our blood is also colloidal system. Blood is also colloid, milk is colloid, smoke is colloid, cloud is colloid. There are many colloids in the nature. So scattering of light by colloidal particles is known as Tyndall effect. So we have given two examples also. Next one. Which of the following salts will give highest pH in water? So here, actually the question is based on salt hydrolysis. Write the point. The question is based on salt hydrolysis. So what is meant by salt hydrolysis? Write the next point. When the anion or cation of the salt interacts with water molecules, resulting basicity or acidity. resulting basicity or acidity is known as salt hydrolysis. Next point. If the anion of the salt, interacts with the water molecules, the resulting solution is always basic. The resulting solution is always basic and pH is greater than 7. pH is greater than 7 and is called anionic hydrolysis. Next point. If the cation of the salt interacts with water molecules, the resulting solution is acidic. pH is less than 7 and it is known as cationic hydrolysis. So to answer this particular question, you require this many inputs. If you know these basics, you can answer this. So what is the first salt given? KCl. KCl is obtained from a strong base KOH and a strong acid HCl gives KCl plus water. This is strong base, this is strong acid. Now what are the ions that come from KCl? K plus, Cl minus. Now K plus, we asked, my dear K plus, from whom you come from? It says, I come from KOH, my father is KOH, which is a strong base. Then conjugate one is weak. So it is a weak conjugate acid. Conjugate acid. Then immediately we asked, my dear Cl minus, who is your father? It says HCl is my father, which is a strong acid. Thus the conjugate base is weak. So it is weak conjugate base. Weak conjugate base. So the cation and anion coming from KCl, both are weak. When both are weak, they can't attack water molecules and do not cause any salt hydrolysis. So write that point. Since both cation and anion are weak, they can't interact with water molecules. That is, cannot cause salt hydrolysis. Hence the resulting solution is neutral.
continue here.
Hence the resulting solution is neutral.
Let's get that.
4. Next, what is the next salt given?
Fortune.
NaCl. It is brother of KCl. So NaCl also. So just I remove this K. So NaCl. So you will do it comes from NaOH and HCl. So NaOH, HCl gives rise to NaCl, which ionizes into Na plus Cl minus. We asked, my dear, Na plus, who is your father? It replied, NaOH is my father, it is a strong base, that's why I am weak. When father is strong, daughter is weak. Now we ask Cl minus, from whom you come from? It says HCl, which is a strong acid, that's why it is also weak conjugate base. That's why, similar to KCl, NaCl also cannot do any salt hydrolysis. Hence the resulting solution is neutral, pH is equal to 7. So what is the third one?
So wait. This about me.
What is the third one?
This says in 5
There's
Na2?
Nazis.
Sodium carbonate. Sodium carbonate. Na2CO3. Which come from NaOH plus carbonic acid. Gives Na2CO3 plus 2H2. This is strong base, this is weak acid. So the formed salt gives 2 Na plus ions plus CO3 2 minus. We already know about Na plus ion story. They always come from strong base NaOH. That's why they are always weak. Now immediately we question, my dear, carbonate ion, CO3 2 minus, from whom you are coming? I am coming from H2CO3. My father is H2CO3. Is it a weak acid or strong acid? Weak acid. That's why it is a strong conjugate base.
Yes.
Strong conjugate base. So the one which is strong will interact with water. So the CO3 2 minus will interact with water. CO3 2 minus is carrying how many negative charges? 2 negative charges. It want to take 2 H plus ions. Each water can give 1 H plus, 1 OH minus. So 2 waters react. It takes 2 H plus ions. So resulting H2CO3, a weak acid. When 2 waters lose 2 H plus ions, 2 OH minus ions are left, which is strong base. So here, who interacted with water molecules? Anion. That's what is called anionic hydrolysis. Look at the point which we discussed earlier. Anionic hydrolysis always produce basic or alkaline nature to the solution pH is greater than 7. So write the same point. This is anionic hydrolysis. Anionic hydrolysis.
But my safe.
Resulting solution is basic in nature. pH is greater than 7.
You should eat it. But it's
I couldn't tell you. Yo.
What is the next one?
Cu is O4.
CuSO4. Cupric sulfate.
Oh,
It comes from cupric hydroxide, which is a weak base, and sulfuric acid, a strong acid.
Jalapenos. Right.
And the formed cupric sulfate plus 2H2O. Now it breaks into cupric ion plus sulfate ion.
what?
What?
You know this. Yeah.
Now cupric ion coming from whom? Weak base. That's why it is strong conjugate acid. Strong conjugate acid.
You can
Sulfate is coming from whom? Sulfuric acid, which is a strong acid. That's why it is a weak conjugate base. Whenever a salt breaks into two parts, the one which is stronger will interact with water. So here who is going to interact with water? Copper 2 plus. Cation is going to interact with water. So Cu2 plus, it reacts with water. Cu2 plus is having two positive charges. It requires two negative charges. Water can supply one OH minus, one negative charge. Thus it reacts with two water molecules. So here it takes two OH minus ions. Each water gives one OH minus, two OH minus. So when it takes two OH minus, it becomes a weak base, cupric hydroxide. And when water loses one OH minus, what is remaining? H plus. When two waters lose two OH minus, two H plus are remaining, which is strong acid. This is called a cationic hydrolysis. What is called? Cationic hydrolysis. Cationic hydrolysis always give acidic nature to the solution. pH will be less than 7. So this much background is there. Now the student should ask me a doubt. If the salt come from both weak acid and weak base, like I will give one more extra example.
I will explain.
Take the example of ammonium acetate. Ammonium acetate. So it comes from acetic acid, a weak acid, plus ammonium hydroxide, a weak base, they will give ammonium acetate plus water. Now this ammonium acetate again breaks into acetate ions and ammonium ions. Now again you ask the same questions. My dear acetate ions, who is your father? Acetic acid, which is a weak acid. That's why you are strong. Strong conjugate base. And you asked ammonium ions, my dear ammonium ions, from whom you are coming? From ammonium hydroxide I am coming, which is a weak base. Thus it is a strong conjugate acid. Conjugate acid.
Good.
So here both can undergo hydrolysis. Here how many hydrolysis occur? Both cationic and anionic hydrolysis occur. If both are having equal strength, then one produces H plus ions, one produces. They again combine to form water, the solution will be neutral. So it all depends on, write the point. In case of salts of weak acids and weak bases, in case of salts of weak acids and weak bases, in case of salts of weak acids and weak bases, the nature of aqueous solution, the nature of aqueous solution depends on the Ka and Kb values. The Ka and Kb values. Ka is called dissociation constant of acid. Dissociation constant of acid. What is Kb? Dissociation constant of base. So the nature of aqueous solution of depends on the Ka, Kb values.
Right.
Full stop. Next point. If Ka is greater than Kb, the solution will be acidic. If Ka is greater than Kb, the solution will be acidic. If Kb is greater than Ka, the solution will be acidic. Oh, sorry. Kb. Oh. If the Kb is greater than Ka, the solution is basic. So in case of weak acid and weak base, what we should know? We should know the Ka and Kb values. This is Ka, this is Kb. If Ka is equal to Kb, solution is neutral. Means pH is equal to 7. pH is equal to 7. So we have completed one topic here. What is that? Salt hydrolysis. So in salt hydrolysis, you have to break the salt into two ions, one positive and negative ion. Positive ion is coming from whom? Negative ion is coming from whom? We have to check. If positive ion is coming from a strong base, it will be weak. If similarly, if negative ion also come from a strong acid, it is also weak. If both are weak, like NaCl, KCl of your question, they can't do weak cation and weak anion cannot do salt hydrolysis. The solution is neutral, pH is equal to 7.